types of diffractions which we have. One is the Fraunhofer diffraction and another we have as a Fresnel diffraction. Okay, so let's go into a little bit details about Fraunhofer diffraction. Now, this is the different types of diffraction which we have seen, the Fresnel diffraction and a Fraunhofer diffraction. As I told you, we have already discussed the difference between both of them, and we have already seen the two types of diffraction patterns, how they are formed in any type of screen. So let's go into details of Fraunhofer diffraction. Now, this is the experimental setup which we have already seen. We are going to details of that particular experimental setup, how it is formed in case of a Fraunhofer diffraction. Now let's understand the details of that. The first one we have S. As I told you, it's a source. Obviously, it's a primary source of light. Keeping in mind that it is monochromatic, we have already discussed the difference between monochromatic and polychromatic. Monochromatic means single color. Now, कहाँ पे रखा है? At F, at the focus of the lens. Converging बोले तो convex lens, which is this lens which we have. So it is kept at the focus of this particular lens. We can call it as y dash. It's not a lens per se, but ठीक है बोल सकते हैं उसको हम लोग. Now, what happens in this particular lens? You're familiar with something called as aberrations. So we are going to ignore completely the aberrations which are formed due to this particular lens. So when we ignore the aberration, what we get as the emergent rays? The emergent rays, as you can see, they're parallel rays to one another and they are present in one particular plane, giving rise to the plane wavefront, which we have over here. Okay. Now, this particular plane wavefront, it is incident on a diffracting element. Diffracting element मतलब क्या? Either it will be a slit, maybe a circular aperture. Aperture मतलब क्या? एक circular size का small hole है. It might be a double slit. It might be a grating. Grating क्या होता है कि element होता है. बाद में दिखाऊंगा if time permits. तो ये है वो O. This is the diffraction element which we have. Maybe a slit, maybe a double slit, maybe a circular hole, और कुछ भी हो सकता है. So this is the diffraction element on which this plane wavefront is incident, giving the emergent ray on the other side. Okay, so these are the rays which are emergent and they are incident on this another converging lens, मतलब convex lens, which gives us a focus on that particular screen. Now, in this particular case, for any particular type of element, you get a diffraction pattern, right? For example, we have discussed diffraction element kaun sa hoga? Either it will be a slit, either it will be a circular aperture. So if it is a circular aperture, then for that S is a point source and the lenses which are used are of biconvex, matlab double convex lens. So if we are using the diffracting element as a circular aperture, matlab kya? Circular size ka ek small hole, then S should be a point source and the lenses which are used should be biconvex lenses. Okay. Now for any linear element we have, linear element matlab kya? It might be a slit, double slit, grating, right? Slit matlab kya hota hai? Line jaisa hota hai. That's why it's a linear element. Double slit matlab kya hoga? Do line hoga aisa. Okay. So for that, S is the linear source and lenses will be the cylindrical lenses. Okay, cylindrical lenses matlab kya? Spherical lenses, they are made from a sphere. Cylindrical lenses, they are made from a cylinder. Right? So ऐसा कुछ तो भी cylinder अगर है हम लोगों के पास, वो cylinder से हम लोगों ने एक lens बनाया. Right? यहाँ पे मैंने कट किया और मैंने एक lens बनाया. तो lens कैसा मिलेगा? ऐसा मिलेगा मेरे को कुछ तो भी cylindrical shape का. तो उसको हम लोग बोलते हैं cylindrical lenses. This is how the lens we will get, which we call it as a cylindrical lenses. and because of that the image we get as a linear image. Ultimately final image यहाँ पे क्या मिलेगा, linear मिलेगा, जैसा ऐसा. So this is how the setup of Fraunhofer diffraction it looks like. Okay, now ये diagrammatic representation है, but actual setup कैसा दिखता है as in the practical setup, it is like this. So you can see over here we have a laser which is a light source. ये filter लगा है यहाँ पे, उसको भूल जाओ. You can see a lens which is over here, a circular aperture. You can see the circular aperture which is present over here. A small hole, एकदम छोटू सा hole है, उसके सामने एक ऑब्जेक्ट रखा है, कुछ तो भी वो नहीं रखा तो भी चलेगा. This will also act as a diffraction element. Here this and this both collectively have as a diffraction element. This is another lens which we have, and यहाँ पे CCD बोले तो अपना स्क्रीन है. ठीक है, कॉफी वाला CCD नहीं. Clear? So this is how the actual practical experimental setup it looks like. Now obviously we are going to see the analysis of this particular experimental setup. So analysis में अपने को क्या-क्या चाहिए, that is what we are going to see. Now in case of Fraunhofer diffraction, this is the diagram which we are going to understand. Okay, both the diagrams we are going to take help of both the diagrams. This is something which we have just seen. ये source है, उसके बाद lens है, plane wave front, ये है अपना element, उसके बाद ये another lens है, और ये क्या होता है हम लोग देखने वाले हैं, getting us this as a diffraction pattern. So in case of a plane wavefront, I told you this YY dash is not a lens, but that YY dash is a plane wavefront which is incident on, let's say, slit. जो कितना है width है उसका, the slit is of width AB. ये पूरा का पूरा अपना एलिमेंट हो गया अभी. This particular point O, let's assume that this point O is the center of that particular slit. So what happens? The center of that particular slit is given by O, and the width of the slit is in the plane of the paper. Okay, so you can imagine it in 3D. So ये slit कैसा है? The width will be something like this. If we are to draw something in 3D, तो एक length होगा और ये होगा width होगा यहाँ पे. So how the geometry can be assessed, that the length is perpendicular to the paper and the width is in the plane of that particular paper. Okay, so that is how it is considered. Now what we have slits, this we can assume to be a slit, or we can consider it to be a slit elements. Slit elements मतलब क्या? Big huge slit can be assumed to be consisting of extremely small thin slits. So that one single thin slit can be considered to be a slit element. So what happens in case of this diffraction? Whenever this plane wavefront, this YY dash, let's assume this is the plane wavefront. So whenever this plane wavefront it reaches this AB, each and every element, a slit element, becomes a secondary source of light, giving us the secondary wavefronts. But now these are cylindrical wavefronts which we have, keeping in mind. पहले ये plane wavefront था. Now this plane wavefront has incident on this particular slit. So what happens? Huygen's theory. Every point on that slit will start acting as another secondary source of light, which gives out its secondary source of wavefronts, which is a cylindrical wavefront. And these wavefronts are responsible for causing the diffraction in all the different directions. Okay. Any doubts till this point? Bolo yes or no? Okay, good. Okay, good. So let's understand the analysis of this. Now again, we are going to take help of these two diagrams only. Let's understand what we have in these different cases. Okay. So now in case of this, so now in case of this, what we have, again backing up a little bit, we have a cylindrical wavefront which is formed at this particular point. तो यहाँ तक हम लोग आ गए that AB has formed a cylindrical wavefront which is responsible for the diffraction. अभी उसके बाद क्या होता है? We have a lens which is kept in front of AB as well. As you can see, this we can consider MN as the another lens. Now that lens might be a spherical, might be a cylindrical lens. We are considering over here that is cylindrical lens with axis parallel to the slit. Obviously, this is how it has been placed, which converges the beams on screen. So this is the one point of conversion which we get. This is another point of conversion which we are getting at focus. So the convergence of the emergent rays after the slit AP, the convergence of the emergent rays, they form on the screen which is at focus, obviously, of that particular convex lens. Now the distance between the slit and the screen will be approximately equal to the focal length of the second this second convex lens which we have used. Now obviously it's not perfectly equal, but it is approximately equal because the convex lens is kept comparatively closer to the slit, so we can ignore the small distance which we have between the slit and this particular lens. Now another point which we have over here, now look at this particular diagram which we have. So this A is the width of the slit which we have considered. The distance between the slit and the screen, you can see, is approximately equal to the focal length of the second lens. The distance D, capital D, you can see is much greater than that of A, as in width of the slit. Just like before, we have seen this in case of interference pattern as well. Generally, for practical purposes, what is the width of the slit is considered? It is 10 raised to minus 4 to 10 raised to minus 3 meter. मतलब क्या? Either 1 millimeter or 0.1 millimeter. And whereas the distance D for practical purposes is considered as 10 meter. So you can see that the value of D, big D, is much greater than A, which is width of the slit. So based on this particular diffraction pattern, now we are going to see the location of minima and maxima. For the location of minima and maxima, what do we have? Now obviously, if you look at this particular diagram, what do we get? We get two set of parallel rays which originate at a slit element. Okay, one set which actually forms at P0. Oh, screenshot. एक मिनट हाँ ले लो स्क्रीनशॉट. Okay. So we have two sets of rays which are originating at the slit element. Which two sets of rays? Again, we have over here one which gets intersected as at this P0. One set of ray which gets intersected at point P. Okay. So Now why two sets of rays? Obviously due to diffraction. एक straight जाता है, one set it gets bent at this particular edge at an angle theta, giving us rise to the two sets. This is set 1 which we have, and this is the set 2 which we have. Now this P0 is the central beam which we have, or the center point which we consider, which is directly in front of this O. O is the midpoint of the slit AB. Keep that in mind. Okay. So this central beam is the central point is due to the central and symmetric beam which is focused. मतलब क्या है? Basically it is nothing but a constructive interference which is formed at point P0 or P0. And what is point P? P is the another point which is formed due to the bending at an angle theta, right? So when we consider point P and point P0, we need to decide whether point P and P0, whether they are related or whether they are not related. Okay. Now, when we consider optical paths, we have already discussed what optical paths are. Optical paths for point P, which is AC. So this optical path can be considered as normal to AM. Okay. So this optical path AC which we have, AC कहाँ पे ये AC है? देखो ये AC है. This is the path AC which we have. So this is the optical path AC. एक कैसे जा रहा है? एक सीधा जा रहा है ना, ये AB के लाइन में जा रहा है सीधा. This is how one wave front or wave is going and another wave is going like this. So this is normal to the AM. मतलब क्या है? In simple words, AC and AM they are perpendicular to one another. That's it. बाकी कुछ नहीं है इसमें. Okay. The most important thing which we have is that there is no path difference or phase difference between these 2 points or these 2 sets of rays which we have. Okay. Any doubts